Hi, Standard 7.2 ratios and unit rates. Standard 7.2, I can find equivalent statements using ratios. So let's define. Ratio is a comparison of two quantities using division. There's three different ways we can write it. This way is the way that we say it, so 10 to 15. Here's our more common way of doing it. 10:15. Your parents write a ratio, they might be writing it this way. But for math class, we want to write it like a fraction, 10 over 15. All right, so that's what they mean by using division. This is a division bar here, so we're using division. All right. A survey asks students with jobs for information about themselves. We're going to write information. We're going to write each ratio as a fraction in simplest form. So we're going to write the ratio, then we're going to reduce to simplest form. Okay? So question 1, 11th grade boy with jobs to 12th grade girls with jobs. So you always want to go in order. The first thing it talked about, 11th grade boys with jobs. We're going to find that number. Let's see, boys, down 11th grade right here. I'm going to write that as our first number, 13. Then I'm going to go for the other one. So 2, 12th grade girls with jobs. Girls, 12th grade, 38. I'm then going to look and see if those can go in there. Let's see. 13 times 3 would be 39, so it doesn't work. Yeah, that's as small as it's going to get. 13 over 38 is the smallest it's going to get. That is our ratio, 13 to 38. All right, so that tells us about 11th grade boys and 12th grade girls. Okay, so that's our chart here. Let's make sure we know our chart too, right? The boys column is these, but both of these, let's see. Both of these are boys. Both of these are girls. Both of these are 11th grade. Both of these are 12th grade. All right? All right. Here's another question. All boys with jobs to all students with jobs. Oh, that's hard, man, because there all boys 11th and 12th grade together? No, but we can fill that information in by adding here. So we could say all grades for boys and girls. So 13 plus 37 is 50. 12 plus 38 is 50. All right. I know that I can go this way too. There's 25. There's 75. Right. And then down here is the total of all of them, which is 100. Right. So 50, all the boys and all the girls from all grades would be 100 total students. All right. So all boys with jobs would be 50, compared to all students with jobs, which would be 100. And then we could reduce this. You could buy 2 a bunch of times. I know that 50 goes in 100 2 times, so I'm going to say 50 and 50, and that gets me 1/2. So our overall ratio is all boys with jobs to all students with jobs would be 1 to 2, or 1/2. Right? Let's do another one here. Another one here, 35 to 40. We want to write it as a fraction. That's easy. So I'm going to take the first number and write that on top, 35. Then the second number and write that underneath, 40. And then I'm going to say, okay, how do we reduce this? Well, not equal sign yet. I'm going to reduce it. Let's see, 35 to 40. Well, this one's in 5, this one's in 0, so let's divide by 5. Divide by 5. That's going to make, boy, rough start, 5. That's going to make 7 eighths. That's my answer. Over here I got 6. This side is 18, so 6/18. And then I'm going to divide, let's see, 6, 1 1/8, 9, so let's try 3. It's going to give me 2 over 9. Nope, not 2 over 9, 2 over 6, excuse me. 2 over 6. Oh, I can do 2 again. 2 equals 1 over 3. 1. All right. I could have just, right, because I have this and this, I could have just divided by 6. Right? So that's how you make a ratio. A unit rate, here's some more information. A rate is a ratio that specifically compares quantities in different units. Example, we might compare 35 candy bars and $10. If I was to say I can buy 35 candy bars for $10, this would be the ratio that we use. Ooh, that's crazy. Unit rate is this same rate, is a rate that has a denominator of 1. So the example, cost of one item or our speed limit. That's per hour, 1 hour on the bottom. It gives us an easier way to identify it, right? So if we did this one into a unit rate, it might be 3.5 candy bars per dollar, right? All right, so let's see what that means. The table shows prices for different sizes of the same dish detergent. We need to compare its unit cost and decide what the best buy is. All right. So what size has the lowest unit cost? The family size or the economy size? So we can figure this out, but let's actually figure all of them out. That'll be easy. So first, the trial size. We want cost per fluid ounce. This says cost first, fluid ounce is second. So we want to start with the money. So we're going to do 0.78 divided by 6. So what we're going to do is we're not just going to divide by 6. I'm going to divide both of them by 6. All right? So that's going to give me 0.13 over 1, or 13 cents per ounce, right? Which is actually just 13 cents. All right, for fluid ounce. We'll put it here. Let's say both those right. All right. Next is the regular one. That's going to be $1.20 divided by 12. We divide both the top and bottom by 12. That's going to give us 0.10 over 1. So it's 10 cents per fluid ounce. Fluid ounce. All right. So 10 cents. Family here is going to be 224 divided by 28. If I divide both by 28, that's going to give me 2.24 divided by 28, 8 cents. 8 cents per 1 fluid ounce. And lastly, let's do purple for economy. I'm going to have 360 divided by 40, by both the top and the bottom by 40. That's going to give us 3.60 divided by 40, 9 cents per fluid ounce. I'm going to go back in here. I want to change this to fluid ounce. All right. So we have 13 cents, 10 cents, 8 cents, and 9 cents. When we get them all compared to the same number with 1 on the bottom, that allows these numbers to mean something. If I had you look over here, you could guess which one's better, but many people would guess the economy. In class, we probably had you guys predict, right? So this is how we compare them. This is the work you need to show, okay? So what's our best one? Well, our winner is the one that we did that was green. The family size is the winner. That's the best purchase price. All right. Find each unit rate. 2 liters of spring water costs $1.98. Find the cost per liter. This is a good way to orientate yourself. You want the cost first, the liter second. So we're going to do $1.98 divided by 2, right? So I'm going to divide both the top and the bottom by 2, and that's going to give me $0.99 over 1 liter. All right. You could also probably call this 0.99 per liter, right? Instead of saying 1 per liter. A car goes 425 miles on 12.5 gallons of gas. Find the miles per gallon. Miles first, gallons second, right? So 425 divided by 12.5. Let's see what that makes. 425 divided by 12.5 gets us 34. 34 miles over 1 gallon, or 34 miles per gallon. Both of those are right. You could do either one. This one over here looks nicer, but it's kind of up to you guys. All right, homework. here's our our chart. You're going to use this chart to answer the first 5 questions. You probably want to add totals to the columns that we don't give you so you can get the right numbers. And then always simplify it. I'm going to really color that in. See that, please. Then you're going to come down here, and I want you to turn all these into fractions, right? The fraction in simplest forms. And on the back, you're going to make a ratio of shapes as fractions in simplest forms. And then down here, it's miles per gallon for the first one, right? You always want to look at this miles per gallon. Dollars per hour, price per can. You want to do your unit rate. Shows all the work and your reductions. All right? All right, thank you.